Okay, this is number 8 in our chapter 3 HL review. Number 8 asks, or says, that a packaging company makes boxes for chocolates. An example of a box is shown below. This box is closed and the top and bottom of the box are identical regular hexagons of side xn. Oops. Question number 8. This is what our hexagon looks like. Oops. Let me start over. Hexagon. Side of x, it's a regular hexagon, which means that all these little triangles I'm drawing are of equal area with a height of h. So we have a hexagon on the bottom and a hexagon on the top with a height of h. Okay, part A showed that the area of each hexagon is 3 root 3 x squared over 2 centimeters squared. Alright, so let's find the area of this hexagon. First, I need to know that that hexagon is made up of 6 of these triangles, right? And because it's a regular hexagon, 6 times. That's a multiplication sign, not x. We know that the radius of each triangle is also x, which makes it an equilateral triangle. To find the area of this equilateral triangle, we divide this into 2 right triangles. And let's draw this right triangle over here. This, the width would be x over 2, and the hypotenuse would be x, which means the height is root of x squared minus x over 2 squared. Okay? That's the area of one of these. So to get 2 of these, we just multiply it. This is the area of triangle over 2, right? So the area of triangle equals 2 of the area of triangle over 2, which is width times height. Over 2. Area of 2 of those would be just 2 times the area of that half triangle. So the area of the full triangle equals, the 2's cancel out, x over 2 x squared minus x over 2 squared. Okay, now to find the area of the hexagon. Hexagon's made up of 6 of those triangles, right? So area of the hexagon equals 6 times x over 2 times root of x squared minus x over 2 squared. That gives us 3x times the root of x squared minus x over 2 squared. Okay. Which equals 3x times the root of x squared over 4. 4x squared over 4 equals x squared minus x squared over 4, because I squared the x over 2 already, which equals 3x root of 3x squared over 4, which equals 3x times the root of 3 times the root of x squared, which is x, over the root of 4, which is 2. That equals x times x equals x squared, so 3 root 3x squared over 2. That is our area of the triangle. Notice that when I do the root of 4, it's not plus minus 2, because if it's a negative 2, then our area will be a negative area, which does not exist. So our answer is 3 root 3x squared over 2. That's our area for hexagon. So part B says that given that the volume of the box equals 90 centimeters cubed, show that when x equals cube root of 20, the total surface area of the box is a minimum, justifying that this value gives us a minimum. So first, I'm just going to expand on our first given variable. Our volume equals 90 centimeters cubed. Volume equals height times width, remember? Oh, base times height. Base times height times base. And our base is our area of the hexagon, right? So our volume, 90 centimeters cubed, equals our height times 3 root 3x over 2. Having this, we can find our height. Our height equals 90 times 2, 180, over 3 root 3x squared, which equals 60 over root 3x squared. Now, we want to find our surface area when x equals that. Alright? So let's find our surface area first. Our surface area equals 2 of our hexagons, right? Times our sides. Oh no, plus our sides. This is our hexagon. We're going to have 6 sides. And each side has a width of x and a height of h, right? So width of x times h. Our area of each of these rectangles is xh. And we found that h equals 60 over 3x squared. 3x squared. Okay? These are our rectangles. These are hexagons. So we know that our surface area was 3 root 3 x squared. And plus 6 times, let's get rid of the x first. Oops. We have 1x, x over x squared is 1 over x. Then 6 times 60 root 3x, which equals 3x squared plus 360 over root 3x. This is our surface area. So it says that show that when x equals cubed root of 20, the total surface area of the box is a minimum, justifying that this value gives us a minimum. Well, to find the minimum of this equation of our surface area, I'm going to use the derivative. Okay, so if there's a minimum, alright, wrong curve, then our equation looks like this. Our minimum would be down here. And tangent to that curve at the point of our minimum, the slope of that is horizontal, so the slope equals 0. So our derivative gives us the slope of this tangent line, right? So our derivative must equal 0. Let's find the derivative first. Derivative of 3 root 3x squared equals 6 root 3x plus derivative of 360. This equals 360 root 3x negative 1. So we have plus is minus 360 over 3x. Negative 1 minus 1 is negative 2. That's our derivative. So to find it when the tangent is horizontal, that equals 0. And we have to find the 0. This gives us, if we multiply, if we move this over, 6 root 3x equals 360 root 3x x squared. Okay? We want to get the x squared away from the denominator, so we multiply both sides by x squared. 6 root 3x cubed equals 360 over root 3. Now we can divide that. X3 equals 360 over 6 root 3 root 3 equals 360 over 6 over 3. Right? So 360 over 6 equals 60 over 3, which equals 60 over 3 is 20. X cubed equals 20. And which means x equals cube root of 20, which proves our original point. Alright, that's the end of the question.